Okay, in this video we will see how to write verilog code for ALU, arithmetic logic unit for 8-bit. Okay, this is just block diagram. So we know that ALU, the inputs will be the two operands, operand 1, operand 2 of 8 bits each, and opcode. What operation you want to perform will be defined by this opcode. Okay, since it is 3 bits, you can do 8 operations. Okay, so these are the output you will get here. That is, the result will be 16 bit. Then these are the flag register. Only we have taken 2 flag, that is carry flag and 0 flag. Okay, so this is the basic blocks. So module ALU 8 bit, opcode, operand 1, operand 2, result, flag and C. Okay, so these are the declarations. Okay, output, so result first we have made all zeros, flag register 0, then carry flag all made zeros. Okay, now 3 bits, no, we have taken parameter which add of 3 bits, so the code for add is 0 0. So when it is 0 0, add 0 0 1, subtract, mul 0 1 0, and operation 0 1 1, or operation 1 0 0. These are the opcodes. NAND operation 1 0 1, NOR operation 1 1 1 1 0, and XOR 1 1 1. Okay, so always at the rate of, here the logic starts, always at the rate of opcode or operand 1 or 2 begin case opcode. This depending on the operation. Suppose opcode and add means actually 0 0 we have added, so 0 0 is assigned to add. So add begin, what we should do, we have to add operand 1 and operand 2, that you have to store the result. So result will be having this. So what is the meaning of carry flag? That means 8th bit of the result, if it is 1, that means 8, uh, then flag should be equals to 1, so this will become 1. Similarly, if the result is 0, that means all the 16 bit of the result are zeros, then make the flag 0 1. Okay, so this will become 1 when this result is equals to 0. So this is 2 are for parity bits, it is carry and 0. Okay, so begin and similarly for subtraction. Subtraction is same, result should be operand 1 minus operand 2, and flag is same, result of 8. That means if the last bit is 1, then carry flag should be 1. Else, for if result is equals to 0, then flags 0 should be set. Okay, so this subtraction point. Similarly, multiplication. Multiplication means the operand 2 should be multiplied. So operator is star. So result. Okay, then flag is this much. That is 0 flag will be active for the itself. Carry flag will not be there. So similarly, and these two and operator symbol is this. Similarly, OR operation, operand 1 or operand 2 is result. We are just checking the 0 flag. Okay, when you perform this operation, if the result is 0, then 0 flag will become 1. Similarly, NAND operation 1 and 2, we are ANDing, then NOT. We will get this NAND operation. Similarly, flag checking, flag 0, 16. Similarly, NOR what? Or you have to do NOT, then you will get result. Checking for this. Okay. Similarly, XOR, we know that this is the operator. Operand 1, operand 2, this will be in the result. 0 flag we are checking here. 16 bit, this value is equals to 0, then flag 0 will be added. And so default begin. default. If the result make it 0, say 0, like 0, and default value. That means if any of the does not match, it will take this value. The results will be 0, all will be 0. So end model N1 N2. So this is about the, if you want for more bits, more operations, you have to expand this. Okay, that's all in this video. Please subscribe to my channel. I'm coming up with more programs on the verilog with mini project level this in the next week. So please subscribe to my channel, share to your friends. Thank you for watching.